Hello, explorers, and welcome to Reach the World's Explorer program. For more than 25 years, Reach the World has sparked student curiosity, bringing real-world adventure, fresh perspectives, and career pathways into K-12 classrooms through virtual exchange. My name is Tim, and welcome back to Reach the World's virtual exchange program titled Deep Sea Detectives, the Search for MH370. I'm excited today to connect with two marine robotics specialists from Ocean Infinity, Marian and Nathan, who are going to tell us all about their work with AUVs, ROVs, and other amazing robotics that help Ocean Infinity investigate underwater mysteries around the world. I hope you've got loads of questions ready for them. I know I do. This is one of my favorite topics of exploration in the whole world, so we've got a lot to talk about today. Warm welcome to all of our classrooms who are joining us today, including Ms. Palmer's class is going to be on camera later with some questions for our guests. If you're not joining us on camera and you're watching the live stream, just a friendly reminder, you've got the chat on the right-hand side of your screen. If you have questions for our guests today, drop them in at any time, and I will fold them into the conversation. And maybe one other final reminder, we have some amazing articles already published on the Journey homepage for this program, including one from today's special guest, which I hope you've already seen. And you are always encouraged to read those each week before joining a live stream event like this, at which point students always have the opportunity to ask their questions directly to experts from Ocean Infinity, which is a pretty cool thing. The link to the Journey homepage is in the chat on the right-hand side of your screen. And new written content is published every week, will be for the next few weeks. So with that, I think that we are ready and finished with housekeeping for today. It is time to move on to the main show. I'd like to give a very warm welcome to Reach the World explorers and marine robotic experts, Marian and Nathan. Let's bring them onto the screen.
Hello.
Hi, Marian and Nathan.
Hi.
Hey, how's it going? It's nice to see you.
Nice to see you, Tim.
And you?
It is wonderful to get to chat with you today. Thank you so much for joining us. I know that the three of us are all in different parts of the world right now, but we're in the same virtual space to talk about one very exciting topic, which is marine robotics and how marine robotics help us investigate mysteries that are happening far beneath the surface of the ocean. A pretty amazing topic. Before we get into how you use robotics, I want to talk about you and how you got into robotics. So maybe we can start with Marian. I'll turn it over to you, Marian, and you can bring us back to when you were a student, maybe in high school. At what point did you realize this might be something you're interested in? How did that path unfold for you?
Hi everyone. Nice to be here. Thanks for inviting me. So for me, it started from an early age. I always loved math and physics. I knew I wanted to be an engineer since I was probably in primary school. And also I think I had that example from my parents. They were both engineers. So I think I got that from them. I didn't know what branch to specialize myself in. But when I was in high school, I joined a robotics club. We were participating on a competition called First, and that completely changed my perspective on engineering and robotics and how you can work together and have a final result that makes you really proud. And then when I joined the university, I chose an engineering career. And I was still on a robotics club, but on this club, we built ROVs for a competition called MATE. It was very exciting. I knew about ROVs because of this competition, and I thought it was really cool that you could have robots underwater and do things there. But I didn't know anything about the offshore industry. I didn't know people actually worked there or did something there. And in my last competition there, in the award ceremony, Ocean Infinity was sponsoring that year's competition. So they were there, they put a video about the projects they had, and I thought their mission was very cool and I wanted to be a part of that. So I started trying to join Ocean Infinity, and now I'm here, not knowing anything about the offshore industry. So it's been like an exciting career path.
Excellent, excellent. And Nathan, how about you? How did you get into the world of marine robotics?
Not quite as organised as Marianne, I must say. So when I left school, I wasn't 100% sure what I wanted to do. My dad, he's a boat builder by trade, a marine electrician, which meant I didn't want to be a marine electrician. So I naturally went down more of a mechanical side of things. I had a Saturday job at like a small place, sort of servicing boat engines and things like that. Eventually did an apprenticeship, so a pretty old school way of learning. Was fortunate enough to learn a lot from that and work for, although it was a small company, they were very good in sort of giving me the time to learn. Sort of went from that. I moved around to a few other companies. I did a bit of welding fabricating for a few years and sort of learnt that trade. And then eventually I landed a job building autonomous boats for the military and oil and gas industry. So similar to what Ocean Infinity does, but obviously on the surface. And then after I'd been there for about 4 or 5 years, I was sort of asked to come over to Ocean Infinity. And a little bit like Marianne, really, that was my first introduction to subsea world. I hadn't really known much about it. To me, offshore life was on an oil rig or saturation divers, and neither of those appealed to me. So to then find this other world that was really fascinating, I wish I'd known it sooner, to be honest.
Well, both of you have sort of ended up by different methods in this career path that is really being defined by the moment. It's being advanced and sort of, new things are happening every single day. What's a typical day like for each of you? Marian, maybe we can start with you again. In your work, working with ROVs in particular, what would a typical day look like for you?
Sure. It depends a lot, and we were talking about this before we went live. You never know where you're going to be. When I first joined Ocean Infinity, I went on vessels to learn how ROVs worked because I was originally hired as an ROV trainee. So I needed to learn how ROVs work, how to maintain them, how to pilot them, because then Ocean Infinity wanted to do remote operations with ROVs and more payloads. But my side was ROVs, and I started to learn how to remote control them from the operations center in Southampton. And I started to realize that I wanted to do a bit more than just operate ROVs. So I started to learn more about the software we use to control ROVs. And I ended up in a tech support position where I help operators with any type of issues they can have during operations. So imagine the operator sitting in the control center in Southampton, and they are piloting an ROV, going through a pipeline, for example, like doing an inspection on a pipeline, and they have an issue with the software or with IT, with communications. So they go to me and they raise this issue, and I try to fix it myself first. And if I cannot fix it, I raise it to the appropriate people. It can be the programmers or developers that do the software. It can be people in infrastructure or communications. It can also be an operator error. That's always very common. And then I focus on training materials so that operators are fully capable of operating these ROVs remotely.
Cool. I'm going to share a really great picture of you that we have. Can you tell us what you're doing here?
Yeah, so that's the operations center in Southampton. And on the screens in the back, you can see the vessel. It was not in Southampton. I believe it was in Norway at the time. And we were doing trials with this new software. So what I was doing on the touchscreen that you see there was launching the ROV from Southampton, even though the vessel was in Norway. So we were doing testing about that. Now this system is like fully live and people use it day to day for different projects.
That is truly amazing. Like, I want to pause there to talk about how incredible that is, that you can be launching an ROV from a control room in the south of England off of a ship that's in Norway. That's not like, that's pretty new, right? That's has not been around or a thing for very long.
Yeah, I know that Ocean Infinity's like mission is to do safer and greener operations at sea. So they started doing this a few years ago, and they were one of the first companies to actually remote control ROVs like in the offshore industry. So yeah, it's very new and it's very cool, to be honest. Like it's a bit mind-blowing sometimes as well.
What a cool thing to be a part of, Nathan. Let's switch over to you. This is a land-based picture of you, which from our brief conversation, I know may not be typical of your typical day, but maybe you can tell us about a typical day for you.
That is a typical day for me. If I'm not on a ship, I'm normally somewhere on my motorbike. But yeah, so obviously my role is completely offshore. So if I'm on a vessel, my typical day is operations. We work 12-hour shifts. Obviously, we use AUVs, so they're a little bit different than ROVs. They're not tethered, and they're autonomous. So we do everything from the launch and recovery sequence, any repairs that need to be done, any fault finding and things like that. Yeah, here you go, this photo here. They're sort of our babies, really. So we use them, day in, day out for our full shift sort of thing. I work on normally a 6-week rotation. So I'm at sea for 6 weeks and I'm at home for 6 weeks. So it's two very extreme polar opposites sort of thing.
Before we get too in the weeds on the marine robotics, which I know we're all very eager to do, can you just give us an idea of what is sort of like the unexpectedly fun parts about living and working on a ship, and maybe the challenges of living and working on a ship? Because for anyone who has never done that, it's kind of a mysterious world. We kind of know people do that.
Yeah, it is. It's trying to explain it to people that haven't experienced it. It's tricky. When I first say to people, I go away to sea for 6 weeks, everyone's like, oh, you're away from home for 6 whole weeks. I'm like, yeah, I get that. But then I'm home for 6 whole weeks. I have nothing to do with work whatsoever. I mean, the fact that I'm doing this is different for me because I'm at home now. Normally, I don't do anything work related. And once you get your head around it, it's a pretty easy life on the vessel. You work a 12-hour shift. So, you get up, you have your breakfast, you go to work like you would normally. The only difference is instead of going home, you go back to your cabin, or, depending on what vessels you're on, there's different amenities. There's gyms, TV rooms, things like that. And you tend to build quite the friendship with the crew that you're on. If you're fortunate enough, like myself, the AUV team's not massive in Ocean Infinity. I think there's 20 of us. So we all know each other pretty well, although we'll work on shifts of 6. So you'll have, 3 and 3. So everybody knows each other, and it kind of it's like you're hanging out with your friends, really. Some days are harder than others. You'll have a busy day where the vehicles just don't want to play ball and you question why you're in the middle of the Atlantic doing such things. But on good days, it's incredible. You can't help but think, I can't believe I'm getting paid to do this.
Excellent. Well, that's a great introduction to you both. We have Miss Palmer's class from St. George School joining us backstage today, and I know they've got some specific interests in marine robotics, and I would like to bring them on Hello, Miss Connor's class. We can see you, yes. And we can talk about a lot of things related to marine robotics today. You've got two amazing experts in the world of marine robotics. So let's, maybe if there's a brave person who wants to start us off with a question, that can get us started and moving in the direction you want to go.
Here we go, John. This is John. And you ready? Excuse me, class. Okay, go ahead and ask.
Do AUVs ever get stuck?
Did you hear that?
Yes. Nathan, maybe that's for you. You're our AUV.
Sorry, I didn't actually hear that, so you'll have to repeat it.
You want to know if AUVs ever get stuck.
They do, unfortunately. So the way these AUVs work is we tell them to go down to the bottom of the sea. They find the seabed, and then it's a little bit like swimming in a swimming pool. So they swim along, and then they match the seabed. So when the seabed goes down, they go down. And the way the system works is if it sees, like a big rock or something like that, it'll either go up and over, or it will turn, go around in a circle and come back. So that side of things, it's very clever. But things like fishing nets and stuff like that, it can't see very well. So they do get stuck in those every now and then, which is not great. It's not a good day.
Lily, yeah.
Yeah, please go ahead. Good question, John. Way to get us started.
Are you sure the plane's in the ocean?
I think she's referring to Malaysian Airlines 370 and the search for that. The question is, are you sure the plane's in the ocean?
I wouldn't know personally. Yeah, who knows? I think that's the $1 million question, I think.
I think that's just a big part of the mystery, right? If it is in the ocean, you want Ocean Infinity looking for it. They're going to help solve that problem. And, maybe even more to the point, Nathan and Marian, I know the Southern Indian Ocean, where the search is being conducted, is very mountainous underwater. It's one of the terrains that maybe you're just describing with the previous question, where there's a lot of clever things that an AUV would have to be able to adapt to in order to effectively scan that. Can you talk a little bit about that unique environment? What are the challenges of programming an AUV for underwater search and terrain like that? Yeah,
so the way we program it is we'll build like a box section, and we'll draw lines. So imagine like a big square footprint of the seabed, and we'll say we want the vehicle to go down to whatever depth it needs to be at, and we want it to follow a line, basically. And that's exactly what it will do. And then it's got side scan sonar, which will map the seabed. It sort of takes photos, kind of, and then it sucks up all that data and it stores it onto a hard drive. And as it's doing that, it's also looking forward to, like I say, look for any big rocks or anything that it could get tangled in. And then ultimately, once it's finished doing that job, because we don't have any communications with it at all, we'll go over it now and then and make sure that it's kind of where we need it to be. But ultimately, we set it off to do the job, and then eventually, when it's done, it comes to the surface and says, here I am. And then we drag it back into the vessel. But like you say, with the mountainous sort of terrain down there, the vehicle does struggle. It isn't as easy as a normal search. It does struggle.
If you can't communicate with it, then how do you find it if it gets stuck?
If that was for me, I can't hear anything.
Sorry, Nathan. Let me repeat. If you can't communicate with the AUV while it is out on mission, how do you find it if it ever gets stuck or goes astray?
That's a very good question. So we have a bit of software that predicts where it should be. So it's a bit of a mathematical thing, because although it predicts where it should be, it's never normally where it should be. So eventually we'll get to a point where we'll move the ship to where we think it should be, and then we wait. And then eventually, like in a movie, you know, like when they see a little radar, you get like a ping. Well, eventually we should get a ping, and then we can communicate with it, but only like rough information. We can't control it too much. However, if anything happens, if it runs out of battery or anything like that, it can bring itself to the surface. And then we've got a couple of different systems. One of the systems is it will send us an email, which quite often, if you have an emergency ascent, that's what it's called when it comes up to the surface, it's normally when you're having your dinner or having a cup of tea, and then all of a sudden an email goes off and everyone panics. And then you get a message that says, I'm here. So then you get the ship sail into that venue or that area, and then you'll get another message that say, oh, no, I'm over here. And you're all right, okay. So then you go over there, and then it'll go, no, I'm back over here again. And it chops and changes, and you have to be looking out for it. They can be cheeky little vehicles at times. Definitely test our patience.
How much do the AUVs cost?
Sorry.
Nathan or maybe Marian, how much do the AUVs or ROVs or these advanced marine robotics cost?
Marian, do you want to go first?
I mean, I don't have a specific number, but it can be millions of dollars. It depends on the equipment. For example, for ROVs, you can have small ROVs, you can have big work-class ROVs, and it will depend on the size and the equipment that they have. Some of them have like robotic arms on them. Some of them have like cutters to cut pipes. So it depends on what equipment is on the vehicle. But for our AUVs, I have no clue.
Yeah, so an AUV is about 5 million, give or take, depending on its sensor spread. It's a little bit, it's easier to put a number on than an ROV, so.
And that's one of these, right?
Yes, that's them. So they're made in Norway by a company called Kongsberg, and they're called Huygens, and they're kind of like the best of what they do, of this type of vehicle. So when we're searching for something like MH370, say, although using an ROV would be amazing because you can see exactly what it's seeing, because, you know, it's on the end of a tether. It's physically not possible to be able to cover so much distance. You know, when we go looking for shipwrecks and things like that, we use these and they cover thousands of miles, you know, a lot quicker than an ROV.
All right, excellent question. Do we have any other questions?
Yeah, Kate.
I think we do. All right, go ahead.
What do you think MH370 got hijacked?
That's an interesting question. I'll let our guests answer it, but their specialty really more is identifying an area of the ocean and seeing if the plane or other things that they might be looking for might be there. So I don't know. Like my guess.
What was the question? Sorry.
The question is, do you think MH370 got hijacked? And I think probably the answer is nobody knows until we find, or the plane is found and more evidence is selected or found.
Yeah, I'd agree with that. I wouldn't dare guess.
Yeah, a big part of investigating underwater mysteries is finding evidence.
Yes.
To give answers to these big questions. I think, you know, a lot of people speculate about what happens under the ocean, and it hasn't been until very recently that we've even been able to dream about looking for clues miles underneath the ocean. And with the marine robotics that Nathan and Marian are telling us about, that's finally possible. So it's about collecting evidence. It's not yet knowing the answers. Sorry to answer that one for Nathan and Marian, but I would imagine that's the answer.
We have another question.
What precautions do you guys take to make sure that the AUVs don't hurt marine life?
She asked, what precautions do you take to make sure that the AUVs and ROVs don't hurt marine life?
Oh, very good. Do you want me to take this, Marianne? Okay, so for instance, I was on a recent job where obviously we were mapping the seabed. So as part of that, we have a team of marine mammal observation people on board. So they'll look for things like whales. They'll also listen for whales and things like that. And basically 30 minutes before we're due to launch, if we hear or see anything, we won't launch. We'll wait until they'll go away. But ultimately, obviously, a lot of marine animals and mammals and things like that are a lot cleverer than us. So when they hear something they don't recognize in the water, because they'll hear it way before we hear them, they tend to just run away from it. You know, they don't tend to be too bothered about us. But, you know, we make sure that the vehicles are clean, they're not leaking oil or anything like that. If they are, they don't go in the water until that's fixed. It's one thing that Ocean Infinity is very proud of, is making sure that we don't contribute to any badness to do with the environment.
And Marian, how would that differ with ROVs? I know they don't move as fast, generally speaking, as AUVs. Do you take any precautions when deploying ROVs?
And and you have camera streams all the time, you can see if there's anything. You usually only see fish, but some precautions that I've known of. There's a hole where the ROV goes from. There's different configurations depending on the ship. The ROV can be launched to the side of the vessel or the ship, or through a moon pool, which is a hole in the deck of the ship. And I know for some areas where there's more like sea life, they need to secure these moon pools just to make sure that there's no, for example, turtles that got caught in the moon pool. So it depends on the area, but I do know that, as Nathan said, Ocean Infinity is investing a lot in doing like greener, like safer operations at sea. And another thing that they're doing as a company is investing in electrical ROVs. So instead of having oily stuff going into the sea, you'll have mainly electrical vehicles, which are safer to the environment as well.
All right, great question, Ms. Palmer. Students, you are welcome to keep them coming if you have more. Let me ask a question while we're getting our next student from Ms. Palmer's class. The ocean is a really harsh place to work. Like when I was growing up, my parents were always like, keep all electronics away from the bathtub. You're gonna fry yourself, right? Like you're putting fairly complicated electronics and machinery very deep into the ocean where it's cold, there's lots of pressure, there's no light. What do you need to build these, when you're thinking about a marine robotic, like what does it need to be strong enough to weather when you're talking about a deep ocean search?
I mean, from our point of view, the AUVs, we run them down to 6,000 meters regularly. You know, so that's deeper than the Titanic. Mm-hmm. And the pressures of things at that depth is just, it's wild. That was the thing that took me so long to adjust to. Obviously, I came from a mechanical electrical background, but I didn't have the pressure side of things. And, you know, the vehicle could be working absolutely fine at 5,000 meters, and then it goes a little bit deeper to 6,000 meters, and then one of the sensors will stop working, and then we'll go, oh, that's not right. Okay, well, we'll have to bring it back up. So we'll bring it up to the surface, and it'll get to 5,000, and it'll start working again. And then, you know, you get it onto the vessel, and you start pulling cables out to start testing stuff, and you can't find problems. And you'll be looking for things like tiny little pin prick holes in like a a rubber connector that
Mm.
you can't see, but at that depth, the pressure is so great that it will just push water into that tiniest little gap. But also vice versa, when they go down to depth, we call them sort of giving it a good squeeze. If you get a vehicle down to depth and it works and comes back up, you're almost reluctant to do anything with it because you're like, no, don't touch it, it works. Because the pressures that everything's been plugged in at, you're never going to be able to get it that tight again unless you put it back down to that depth. There's always that. If we have a vehicle that's been sat and not used for a few months, and you're going to have to go and put it down to a deep depth, it's always a bit like, oh, I hope it's going to work.
All right, Marian, anything to add to that?
Not really. I only remember when I was in school in university and we were building these ROVs. Of course, like we in Ocean Infinity don't design ROVs and AUVs. We buy them from other companies that design and build them. But when I was building an ROV at school, like it's mind blowing to think that some piece of electronic is gonna go in the water. And we tried to do a lot of things to get it sealed from the water, but it's so hard. So there's a lot of electronics that are not like certified to be at certain, and it wasn't even deep waters for us, it was a pool. But there are things that are not, they can be waterproof but not certified to stay in the water for a long period of time. So like learning how to seal things properly, it's like a thing that is like a life changer when you're working with electronics and water.
Yeah.
I think one of the things the ROVs have got that AUVs don't as much is a fair amount of their electronics are actually encased in oil. So, like the main junction box on where the power comes into the ROV is obviously, it's thousands of volts. I think it's about 10,000 volts. Goes into a box, which is a plastic box that's then filled with oil, a special type of oil, obviously, with like it's called a compensator. So it's like a bag of oil with a spring on it. So the spring doesn't push much, but it's just enough to keep the pressure above whatever's outside. So it never, it won't implode.
Great example of creative problem solving. Ms. Palmer.
These guys are making sea perch ROVs. I don't know if you ever did that, either one of you, but they are using wax to seal the electronics. What do you use, Marian, to seal the ROV that you built when you were in high school?
We used to use resin, like the clear one. We used to fill like everything with resin. That's one thing I remember. And then just everything that says waterproof on it, to be honest, it's just trial and testing, leaving it in the water for a certain amount of time. And as Nathan said, if it works, don't touch it until
Right.
it doesn't work anymore.
We have another question.
Sure.
Why look for MH370 out of all of the missing planes?
Good
Why is
question.
that?
Good question. There's a lot of mysteries on the bottom of the ocean. Why go looking for the missing Malaysian airliner?
I
mean-
think one of those things is, oh, sorry, go on, Marian.
No, go ahead.
I was just going to say, I think mainly for the families, just to get a bit of closure, I think, and just to see if we can learn from anything. I think that sort of incident, there's always going to be questions. I think it's one of those things that a lot of people will want answers.
Yeah, and maybe as a follow-up to that question, do you ever find things you're not looking for? Like if you go looking for something, you're ever like, whoa, that's definitely a shipwreck, but that's not what we're looking for. Like, does that ever happen?
Yeah, that's happened to me. So part of the AUV world, like I say, is obviously we'll look for stuff like that. So, for instance, we were out looking for a particular type of shipwreck, like an old galleon style. So the way that works is the AUV goes and scans the seabed, builds up a picture, and then we get the information. And at the time, we were taking photos, just like a camera on the bottom of the vehicle. And we were flicking through the pictures, and it was like seabed, rock. You're like, okay, seabed, oh, crab. And all of a sudden, there was a big gun turret from a World War II vessel. Just this turret in the middle of nowhere, and we were like, huh, that's strange. So we carry on clicking, and as you click, like, it jumps forward a little bit, and then we got to like the stern of a ship, and we were like, oh wow, you know, and the detail's pretty good. And as we're clicking, obviously we're going over the top of the ship, and it got to one photograph where the mast of the ship must have been about that far away from the bottom of the AUV. So all of a sudden it just came to this picture, and it was like, boff, this big stick right underneath the vehicle. So we were like, oh, you know, none of this was what we were looking for, but we found it. And that's the weird thing, especially from my point of my job role, is I'm sort of firsthand seeing that side of things. You expect the seabed to be full of loads of stuff or lots of rocks and things like that. The majority of it is just boring sand. You don't necessarily realize it until you get to other places. So when you look at like the side scan data that we get, you see like this big blob, and you're like, wow, that shouldn't be there, sort of thing. And then that's normally where Marianne's team will come in with an ROV and go down and have a look, and they can get proper feedback. You know, because it's almost like a camera on a stick. You can go down, have a look, especially if it is a shipwreck. You can have a look around, and it's pretty cool.
Amazing. Ms. Palmer's class, can you tell us more about your ROVs? What sort of challenges are you facing, or what sort of other issues are you working through that maybe our experts can help you solve?
I don't think we have any brave souls that want to tell you, but basically we divided in half, and one half is doing the controllers right now, and that's not my half, so I don't know what's happening with that. They're doing the electrical work, and then my group is putting the motors into casings and filling it with wax and making sure that no water will get in. I think they don't have a sense for how hard that actually is yet until we try them in the pool.
So are you going to eventually, you'll be testing your ROV in a pool at your school?
Yeah. Well, we don't have a pool at our school, but a pool nearby.
Yeah.
Yeah.
Very, very cool. Yeah, I was talking to Marian before our call, and she sort of grew up participating in competitions like this or tests like that. And it's so cool to learn how, you can start by doing a project like this. And if you really like it, it can become a job like Marian has right now. It's definitely something people will pay you to do if you're really good at it. So if you really like this project, just look no further than Marian for what this can become in your life. I think both Nathan and Marian have said to me, I can't believe people are paying me to do this. It's a pretty cool job path.
I agree.
Cool. Well, if you if you want to think a little bit more about some more questions, you can do that. I'll move you backstage. Just wave to me if you have any more questions. All right.
Anybody else have questions they want to ask? I think we're done. It's almost time to go anyway.
Totally get it. All right. Thank you so much for joining us, Ms. Palmer's class. Great to have you here.
Can you guys say thank you?
See you later. All right. So before we move on, I would love to just ask you both, what's your absolute favorite part about what you do? And what is the hardest thing about what you do? Sort of polar opposites of the whole scheme of things for your jobs. What do you love the most? what is like a constant challenge or the thing that takes the most effort in your daily work?
I can start with that one. I would say for me, either my favorite part and my least favorite part is traveling. So before joining Ocean Infinity, like I've never been to Europe or like many places. I'm originally from Mexico. So like Mexico and maybe United States were the only countries that I visited, and only because I live in the border. Well, I used to live in the border. So like being able to travel and meet people from different nationalities, learn from them, that was like it's a very cool part of the job. And Nathan would agree that he's on a like 6-week rotation, that every 6 weeks he gets to visit like a different place. And that's a very cool thing about the job. But it's also hard to be away from home like every now and then. So I would say it's my favorite part of the job, but it's also my least favorite part of it.
Yeah, I think I'm very similar on that. You know, the camaraderie that I sort of mentioned earlier. You know, you're working with your friends. You know, last month I flew out to Bahamas, had 3 days doing some work in the Bahamas, and then we sailed across to Miami, done a little bit more work there, and then we sailed across the Atlantic and ended in Portugal. So you know, you're seeing 3 countries in in a month, and doing it with some of the coolest people and people with different backgrounds. You've got different nationalities, and everybody brings something different to the group. Different sort of different jokes, different you know all this sort of difference, but you're all in it together, sort of thing. The thing that makes you all the same is the fact that you're on a ship and doing a similar role. But like you mentioned, sort of being away from families, tough. I've got a 11-month-old baby boy that I miss dearly. I mean, I'm lucky the fact that because Ocean Infinity is such a technological advanced company, I can FaceTime him 3 times a day, and I do, and there's no lag. It's not like a one email a week or stuff you hear from the good old days. So I don't feel that I miss out too much. But then the flip side of that is obviously then when I'm home, I'm off for 6 weeks. There's not many jobs out there where you only work. I only work half a year. There's not many jobs out there that you get that much time off. So I think if you use that time off well, it's almost like you don't miss it, sort of thing. So it's good on both sides for me, at least. It works for me. It's not for everyone. It takes a certain type of mindset and a good family and things like that. My wife, she's very understanding, so as she has to be. But it works, And
Yeah.
like I say, if I had, because I used to work in the office at Ocean Infinity for the first couple of years, and I'd have less time at home doing a 9 to 5 office job than I do on the rota that I'm on now. So it's, you take the good with the bad,
Of course. Yeah, sure. Great answers. As we wrap up here, we're in our final minute. If you could give one piece of advice to young people who love tinkering with electronics and mechanical parts and are interested in the ocean and, really find what you're doing right now to be an interesting possible career path, what advice would you give to young people? Marian, I'll have you go first.
Sure. I would say that you're already ahead of us because you started like earlier. I would have loved to be like building an ROV at the age of these kids. Like I was way older when I got into robotics. So I wished I had the opportunity to do that. So you're already ahead. And I would say if you don't like that, try anything else that you are interested in. Don't stay with what you learn at school, try new things outside of school, join clubs, join a book club, join a robotics club, just to meet people. Like, networking is very important, like in your professional career. So just getting to know more people, what they do, and learning like new skills for life, that's like very meaningful. So I would recommend, just like, if you're interested, just go for it, and everything will be valuable. And one more thing, don't be afraid if you don't know what you want to do. Like, most of us don't know what we want to do either, so it's fine not knowing what you want.
Great advice. Thank you, Marian.
Yeah, 100%. I'll carry on from that about not knowing what you want to do, and don't let that shape you. I mean, when I left school, before I done my apprenticeship, I went to college and studied music for 2 years. Randomest thing ever. Don't get me wrong, it was amazing 2 years. I really enjoyed myself and loved it. And it was the break I needed, I guess. And then when I got back into working on tools and things like that, even then it wasn't like a straight road. You know, I did different jobs to learn different parts of different techniques of how to do things. And I think knowing, you know, the guys that are watching this now, knowing the sort of roles that are out there and the amount of information you can get online, I would 100% recommend it. It's a cool industry. It really is. And even if you think it's a bit of a niche, that whatever it is you want to do, you know, you might not want to do just electronics. You might want to do some mechanical side of stuff with it. Well, they go hand in hand. And, you know, being open-minded to all these sorts of things and just putting yourself out there is probably the best thing I would recommend. And also, don't be afraid to fail or drop back on stuff. You know, it's easy to make something and then it not work, and you go, well, that's it doesn't work. And, you know, most of my career is full of days like that. You know, I'll repair something one day and then it breaks the next day, and I'm like, well, what can it be? And I think leaning into that and using that as a challenge to challenge yourself, yeah, I think it's awesome. And reach out to people, like Marianne said, you know, networking, speaking to people, speaking to yourself, Tim, or a teacher, or, you know, even some of these big companies, you can reach out to them and just sort of inquire about information and stuff like that. The majority, I know Ocean Infinity would always try to get back to people that are showing interest, you know, because that's kind of at the core of what they want to be doing. And it's not just them, you know, there's lots of other companies out there that do it and offer it. So yeah, definitely do it.
Great. Thank you both. And I'll just summarize by saying I don't think that 10 years from now we'll be running out of mysteries to solve on the bottom of the ocean. So if you like this career path and you think what Marian and Nathan do is pretty cool, there will be plenty of mysteries and questions to solve and investigate on the bottom of the ocean if you bring that skill set to it. So that is about all the time we have today. Unfortunately, I need to wrap this up here. But I want to thank you all, especially Nathan and Marian, you two, for joining us and sharing your work and career paths with us. Fascinating to learn about. For our educators and students, keep an eye on the Deep Sea Detectives Journey homepage. Again, the link is in the chat on the right. For new articles, we got a couple more weeks to go. We're going to meet a few more members of the Ocean Infinity team. So make sure you keep collecting your questions. For our friends at St. George, good luck with that ROV, and I hope the water testing goes well. Hope we can hear about it after you do it. And until next time, thank you all again for exploring marine robotics with Reach the World today, and we'll say goodbye for now. Have a great week.